Thank you, guys. I feel honored to be here, and I don't want to hold you any longer. And this laptop is a custom setup, so this is like Gen 2 with i3, so I hope it's not gonna break. Okay, we'll see. So let's go. So yeah, right now I'm working on this project called PopLocker, and it's completely open source. It's available to everyone to download and experiment with. And it's founded by the Ethereum Foundation from the grant. So each month they give us, or each 3 months they give us some money if we are nice and we pitch. And yeah, we then develop for that money. And right now we're doing this for web extensions and specifically Chrome browser. But we have plans to introduce some rich clients like the mobile or our own browser. So, but for now it's the web extension. Let's page down. So what does it do specifically? So it's a dApp browser, and if you heard the term dApp, that's fine, but not many people did. So dApps are distributed apps, and that's it. Yeah, they're essentially websites that have that are blockchain enabled. So you can think of it as the blockchain enriches the website, and they make use of the blockchain capabilities to do some interesting stuff. And this picture, it pops up everywhere on the blogs of people who put hashtag decentralized stuff on their Twitter. So let me just quickly explain, because this is really interesting. So obviously the first one is the centralized network, but then you have this decentralized network. And this is interesting because people say, oh, we need decentralization and stuff like this, but they don't realize that what you want is distributed network, because this decentralized network still has hubs, and it's still vulnerable. And this is the network that we have today, the internet of Google, Facebook, and all that shit. So we want to move to mesh-like networks. And also people confuse blockchain with this. So blockchain is distributed, but not in terms of state. I mean, you can treat blockchain as the database, which is eventually consistent. And it's distributed among many computers, but basically it's just one state. So you can treat blockchain as one computer. And that's what the guy behind Ethereum thought. Why don't we make a global computer based on the blockchain? I know it may be confusing, but it's just all about distributed consensus. So all these computers, thousands of computers in the blockchain network, their job is to come together about the state of what they're holding inside the blockchain. And that's all there to it. I mean, the blockchain makes it clever so that you don't have to trust each other to actually hold the same state. And Bitcoin is the prime example, the first successful blockchain network. But the key difference between Bitcoin and Ethereum is that in Ethereum you can put arbitrary data on the blockchain, and not only transactions, which makes it eligible for computing operations. To be fair, Bitcoin also has the scripting capabilities, but as people from Ethereum argue, they're not Turing complete. It's a simple stack-based machine, and there are some limitations, many limitations. But this is Ethereum pitch, so yeah, in Ethereum blockchain, you can actually perform Turing complete operations. I don't know if you can see this. Yeah, that's a but. Yeah, I messed it. Fuck up. Anyways, you have like full-fledged virtual machine that executes operations. And the way they do this, they execute operations one by one, and you can see they have loops, they have variables and stuff, and jumping and all that shit. But the thing is, when you have these operations, what happens if you run into infinite loop within this computer? I mean, then all millions of computers would have this infinite loop going on, and the whole blockchain basically becomes unusable. So they solve this with gas. So actually, this is quite good name because the analogy is one-to-one with the gas in your car. So you have a gas limit, which is like a tank that you just put gas into, and that's how high the gas limit is. This is how far you can go with the operations on the blockchain. You have gas price, so you have to actually pay the ETH, the equivalent of the Bitcoin in Ethereum, the Ether. You have to pay for the gas, and of course you have gas, which is like a unit without any, how do you call it, unit in itself. So yeah, so when you have the infinite loop, sooner or later it's going to run out of gas that you bought, and it's going to end. And all this stuff enables you to have this smart contract functionality. So smart contracts are basically programs put on the blockchain as a transactions that enable you to have to do many different stuff, and this is essentially what the dApps base on. And this is the website. Of course, nothing visible, but this is called State of dApps, and you can visit it. And they have like over 2,200 different dApps. And it's very interesting list of dApps running on Ethereum and other blockchains, and it's very detailed, and it's really nice site full of interesting stuff. So they have these lists. Yeah, shit. Some prime examples. The first one, Golem, is they say it's a worldwide supercomputer. So they basically make use of the fact that people on the blockchain, they must have computers, right? So you give the computing power to the network, and you earn money for that. And that's realized by the smart contract. So the contract is secured in the blockchain, and you can safely give people power, and they can use it for rendering and stuff. You have something like Augur, which is a prediction platform. It's interesting. They're using this interesting phenomena. So if you have a jar of beans and you ask people how many beans are in this jar, if you ask sufficiently enough people, their answer will approximate the true number of beans in a jar. Somebody says 50, somebody says 5,000, and sooner or later, the answer is going to approach the truth. So in this prediction network, they ask, for example, what is going to be the stock price of Apple next week? And random people just, I don't know, 5. And sufficiently enough people will give the right answer. That's the statistical phenomena behind it. You also have, of course, auctions, the crowdfunding with friends' fingers, and you have Tamagotchi-like stuff, like crypto kitties. You can have your crypto kitten that you grow, and then you can sell it for another. And you also have Ebola virus on blockchain. So somebody puts the whole genome of Ebola in the blockchain, and this is the address. You can download it, and I don't know. If you have a DNA printer, go ahead. Yeah, so how to make this dApp, right? One does not simply put blockchain on a website, right? So This naive approach would be like this. You have a user with the laptop, you have some front end, yeah, CryptoKitties. And then the front end makes a contact with the back end, and back end does this. They have the API for the Ethereum virtual machine, and nice. But the problem with this approach is that it's not really decentralized, and your identity is kept on the back end. So it's not really your identity. They manage it for you. So it's bad practice. It's like doing these wallets with Bitcoin that are not yours but on the internet, and some shady website like Coinbase asks you for like your passport and whatever stool sample. So how to get around this? You can have user talking to EVM directly, and the front end just using user's connection to display some stuff, and maybe enrich the website with some data from the backend. Maybe, I don't know, history of the transactions, their friends list, whatever. But the thing is, they have no idea about the user identity and the user transactions, and user can keep everything secured in the public keeper stored in the laptop. And that's how the dApp browsers work. So they enable dApps to connect to EVM through their logic, and that's where PopLocker comes in. And PopLocker is the dApp browser for your browser. It's an extension. So it's all about, like I said, about the connection. It connects you to EVM. It identifies you within EVM, and also provides a way to authorize transactions by the user. What I mean by identification, it's not like they have some database of your IDs of you or whatever. The only way, you just need to have sufficiently random number to be identifiable in the blockchain. So 160 bits, if you randomize this 160 bits, that's your ID, that's your IP, whatever. That's all there is to interact with the blockchain. There's no logins, no registrations, no sending messages, and logging into the machine. 160 bits, sufficiently random, and you're in. So yeah, so PopLocker, firstly, it generates your ID. You just basically create your password, click create account, which basically creates your private keeper that's stored in the storage of the extension on the local machine. And then, nothing's, yeah, sorry for that. Anyways, this is the screen to authorize your transactions. So you put your password there and hit authorize. The password, of course, doesn't go anywhere. It's just here to unlock the private key that signs your transactions. So Ethereum knows that these transactions are signed by this address. This is the advanced view. You see nothing here, but the idea behind PopLocker is that it's supposed to be very simple. So there are only two ways to interact with the transaction. You put your password, and you can set, there's a slider, you can set the amount of fees that you want to pay. So slower, faster, and that's it. It's simple, and it's supposed to be good enough for people who have no idea about Ethereum. And yeah, so to sum up, the PopLocker is it's a middleman between your dApp and ETH, and so sometimes it doesn't really need to contact blockchain to interact with the dApp. So if you generate address, it actually stores it locally, so it can send it back to the dApp without contacting the node. And this is the most important part of the extension. So transactions. So like in Bitcoin, you can send money, but you also can sign the transaction to do voting, to do some calculations, whatever comes to your mind, because transaction is also associated with the smart contract, so with the program on the blockchain. And the PopLocker signs these transactions, authorize it for you. So DApp sends the transaction with the ETH in mind, but it gets captured by the PopLocker, sign it locally, and then the transaction signed, the raw format is sent to the ETH. And DApp thinks it talks directly to the ETH, but it's not true. And I have to mention this because some of you may already use it. There is our competition called MetaMask. And these guys, first of all, they have monopoly, so it's good, always good to introduce a new player. They are not aimed at the like a novice user. It's very complex. They have worse keeper management than us, and they also tend to bundle everything with their app. So they have wallet, they have some identity management, everything crammed into the extension, which is not a good practice if you are practicing decentralized or distributed internet. Okay, so enough of this, and let me talk. How did I get to this point, and what was my journey to here? And so first of all, the client found me. I didn't advertise, hey guys, I want to work on the blockchain. I've never did this stuff before, so it was quite interesting that they reached out. And the client was okay that I will need to learn this stuff from the ground up. Nothing was, I didn't know much about this. Only that I was interested, and I pitched some ideas that sounded like I'm a professional, but you know. Okay, so first I did a lot of reading. So they found me through this middle guy, the office. They are called Ops Talent, and so I'm using their office to develop this application. And for the first 2 weeks, I was doing nothing but reading. So I was just sitting with this laptop and just like, okay, nice. And the people there were like cramming some stuff, right, coding, and they were like, what the fuck is he doing here, right? He's just reading, he just does nothing. And I'm like, let's see how it goes, you know. I was reading to just get a feel around the community and around the task that I need to do. And believe me, the amount of knowledge, amount of technology loosely interconnected with each other is staggering, and you can easily lose yourself there. So first thing I did, the very first thing, I came back to this video that I have saved on my playlist. It's really good. I recommend you. 3 Blue, 1 Brown. He talks about Bitcoin and blockchain in general in a really nice way, full of really colorful animations and mathematics. It's really good. I recommend you to get the basic grip on how blockchain works. And it turns out that this application is really simple. It's really simple to once you view this. And there is this welcome to Ethereum wiki. So there's a wiki that Ethereum has that is also a great entry point for you. This is the entry to the rabbit hole. You have links leading to links leading to links. But the most important one is the white paper. It's like very good summary of what Ethereum is and what technologies they're involved in. And yeah, the white paper. And there's also documentation. So the Homestead is the stable version of Ethereum. And there are different stuff in the wiki and the documentation. They're both very extensible, and you have to cover this and that to actually get a grip on it. And so, like I said, this is like entering the rabbit hole, and there's far more to know. And there's also this yellow paper, which is very technical description of how the blockchain, Ethereum blockchain works. So you don't need to read this to work with the Ethereum. I haven't read it fully, but there are some informations there that can be beneficial for you in the future. So I will go back to this later. So, but at the top level, it's really pretty simple. So you have like this technology, like for example, get client, right? It's get client is like a Go that has JavaScript engine built in, written in Go. It's fucking madness, man. But the thing is, you don't need to know this to interact with blockchain. All you need to do is to get a grip on the web3.js. I know this is the Ruby conference, and I'm talking about JavaScript. I hate it as much as you guys. I think they had the CoffeeScript and they fuck it up with the ES6. But what can you say? People are stupid. But turns out that Ethereum has this weird boner for JavaScript. So, like I said, they have it in their original client called Geth. They're using it to interact with the smart contracts, and you can use it as a wrapper in your projects. And this is a wrapper for JSON RPC API, which is really, really simple API. It's just JSON. And this, funny enough, about getting knowledge, I was using their GitHub JSON API, the Ethereum one, but I couldn't find it for the purpose of this presentation. They just went dark, I don't know. So there's the Parity one. Parity is another Ethereum client that is written in Rust, and it's supposed to be super fast. They have this API documentation. There is a number of methods. That's all the methods that you need to interact with blockchain, which is, I think, it's pretty nice. And I'm using only like, I don't know, 5, maybe 4. And that's how the data looks like. So basically, you can curl. You can use curl to interact with the blockchain, and you send the JSON with the method and with the params. That's I think the only require things fields to interact. And yeah, if you have a client on your localhost, you can use localhost, or you can use something called Infura, which is like this hosted node that is basically abomination because it's a centralized node. So MetaMask uses it, and we also use this. But I have a plan to get away from this Infura. It's like Heroku for Ethereum, let's just say it. But I want to introduce node discovery like on the torrents, and actually in Ethereum itself to this extension, but later. I don't have time for this shit. So this is a response, also JSON, and as you can see, it's very simple. It just says result, and the results are always in arrays. Params are always serialized into arrays. Results are in arrays. That's all to it. Congratulations, you are blockchain programmers. And this is what gets injected to the web page to make it an app. So the app essentially has its own, expects to have this window.web3 non-null with the current provider field. So the current provider, this proxy provider is mine, and they expect it to be defined. And once you have it, the Web3 implementation on the dApp takes over and makes your life easy. You don't have to write API for the blockchain. They will use Web3, and you just have to plug the current provider into yours, and that's it. Yeah, and that's how within the extension, that's how I interact with blockchain, with the RPC. So I have a RPC thingy that uses HTTP to send JSONs over the network to the RPC URL, which is inferior right now. So you can also use WebSockets, and I would gladly use this right now. This is my regret that I went for HTTP instead of WebSockets, because in WebSockets, in inferior at least, you have this possibility to have push notifications from the blockchain, which is really nice when you monitor, for example, for the transaction whether it was mined or not. So you can actually have it for free instead of paying for it. But fortunately, I programmed the provider, the RPC provider. I programmed it this way that it's relatively easy to switch. But I don't have time for this right now. So if you want, you can issue pull request for this. Okay, so challenges. There were some challenges programming this. So first of all, the extension API. So this is how basically the web extensions work. So you have like your click on this and some pop-up comes in, and you have the pop-up HTML which defines your UI, and you have pop-up JS that defines your logic, and there is also background JS that runs in background, but it's all it's evented, so everything is async, even access to the storage, local storage, not the local storage within the website, but local storage within the extension. It's async, reads and writes. So you have to take into account that everything is done with promises. Shit, 5 minutes. And there's also content script that injects stuff into the website. So that injected logic then ends up in the DApp. And I showed you the injected logic, more or less. This is how the this is the diagram for the Chrome extensions. So you can see this is a big pile of shit, and you have to find your way around it. But don't worry, you don't use much of this. Anyways, pop-ups. So when you click this, send money to somebody. It's not money, it's tokens, supposed to be tokens, but whatever. You want to open my extension, right, to authorize. But the thing is, you can't, because Chrome, in its infinite wisdom, prevents websites to open the pop-up, which is security reason, I understand. So you have to make yourself around this problem. So MetaMask had this thing that they would open the regular pop-up on the web page. The DApp would open the pop-ups through the injected script. But these pop-ups have the limitations of not having password here, because everyone can open pop-up. The malicious DApp can intercept this and create its own pop-up that looks the same and ask you for password. So that was a security risk. So they just did these buttons, and the thing is, it's bullshit. And because you want to authorize your transactions all the time, and they would open the session, so you wouldn't authorize your transactions, but only session. And we want to type every time you authorize something, you type your password. So what I did, I found out that there is this API for listening to changes within the local storage. So then I created the transaction, saved it to the local storage of the extension, and made this badge appear on the pop-ups icon. And I pitched to the client that this is a good UX. And it actually is. It actually is. If you think about it, when you are signing a transaction that sends money, you want to do everything proactive. So you click send, and then this badge appears. And then you click it, so you know that you clicked it. Nobody displayed some pop-up, and nobody made you to click something, to interact. You were the initiator. And funny thing enough, after I implemented this, MetaMask did the same. Yeah, I'm just joking. They don't even know about us, so. But I was first. And yeah, you click it and then this appears. And it's quite clever because it is. Because you have promises. The dApp waits for the response. Everything is async. And you have to open the pop-up and respond to this promise. Right, and it's fine. It's nice that even if you reload the dApp or you go offline, you still have this transaction saved, so you can sign it, authorize it later. Something, offline PWA stuff for free. And also another problem, nonces. So each transaction has its number, and it turns out the number has to be like 1, 2, 3, 4 in hexadecimal. I don't know hexadecimal, so it's good that until 5 and until 16 they are fine. So no skip-dooby, so you can't skip nonces like here. Why this is a problem? Because, like I said, user can go offline. You want to sign multiple transactions at once. And you have to remember that you have to wait for Ethereum miners to mine the transactions, to confirm them. And it takes them some time. It can take minutes even, if you are a cheap bastard and you don't pay your gas price. So, so this is a problem because you can branch out your local nonces that you monitor in your extension, and with what's on the blockchain. So, and if you do this, if you have different nonces that are on the blockchain, they won't tell you that because this is distributed networking. There will be no error, and simply the transactions won't be mined, and you will be losing your mind. What's wrong with this? I spent 2 days thinking about this shit, and there's the answer in the yellow paper. So that's where it comes handy. So yeah, no errors. This is distributed networking. This is like a fail first kind of shit, and fail silent. Okay, and also this is funny thing. Chrome limits size of the pop-up to 600 pixels, so you have to cram lots of stuff in 600 pixels. And we, of course, did this. We found this out pretty late, like really late. And this is something we would just simply find out what are the size limitations of the pop-up, but who would care, Yeah, and also, what's gonna be different from MetaMask here is that we're also working on something called Smart Blocker, which is a pretty ingenious way to authorize multiple devices that you use within this by the smart contract. So this way you don't need to have like a single public private key pair that you need to store, export, and like put it on some USB drive or whatever. You don't need to do this synchronization. It's in MetaMask they do this, but here you can authorize devices by one device by another device, and have the devices and manage the devices by the smart contract, which is pretty neat. And this is something new that they don't do this. And also some stuff that I forgot to mention: EIPs. This is the RFC of Ethereum. Go there to see what's coming, and what to be ready for the changes. There was also a challenge related to key generation. So if you want to generate keys that are not infected by the Intel and NSA, then you will have to take slow approach. Don't use system calls, don't use the browser backend. But then it takes 20 seconds to authorize the transaction and heats up your laptop. So take this into consideration. There is also WhisperNet, which is basically publish, subscribe messaging on the blockchain itself. So the Ethereum blockchain is not only the database, but also a true distributed network for communication. And this is what we are using with the smart locker. We can sync the lockers using WhisperNet, and also this is offers the opportunity for something called gas relayers. So the thing is, our smart locker functionality, they sign the transaction that is meta transaction, and in order to move it without losing gas, we are using these gas relayers, which are like computers run by some people, and they can earn some back on it. This is a possibility to have a real business here, people. And yeah, I forgot, and I didn't want to talk about smart locker right now. There is so much to talk and so much to show that I have no time, unfortunately, and you're tired already, so let's be done with this. I had some demos, but I don't know, this screen is really awful, so let's just, yeah, I know. You have questions for me, or you want to see some?
We want to clap first.
Yeah.
Guys, let's have questions.
Is it possible to perform some blockchain calculations in browser with help of JavaScript without user confirmation? Just earn some money.
Yeah, no, everything which enters blockchain, you cannot do blockchain stuff outside the blockchain. But of course, you don't want to put everything on the blockchain. You know, that's put this on the blockchain. This is blockchain is only database and a really slow computer, because the operations on the smart contract, they need to be mined by millions of computers. So it's really not feasible, not a good idea to put calculations on the blockchain. You put stuff that you really need to, and you can do off-chain calculations yourself. So think about this way. Blockchain is the way to ensure, for example, that you did calculations, but you do calculations off-chain. And there are really clever stuff, actually, that mathematically ensures, for example, that you did the right calculations for the right price with the right result. And this is something called zero-knowledge proofs, and I have no time to discuss it here. So, but yeah. You could ask me anything. Yeah. I have a laptop here with the stuff. What else? Yo.
Okay, what about your part of the talk when you told about the problem to compute in distributed network?
Yeah.
What about the current existing model implemented in the video cards? So there is like
Yeah. Sorry. Where?
there is video cards, like computers.
Yeah.
Cards.
Yeah.
So you have masters, and essentially all the video card processors
Ah.
they are like inside mode.
Yeah.
So you have like controlling master. You can make like some sort of like 100 masters and
Yeah.
10,000 of these slave nodes. So
Yeah.
the masters should have some sort of consensus protocol.
Yeah.
So they aren't locked up in some loop.
So you're referring to this Golem startup?
I was referring to your part of this speech, but
Yeah.
so there is essential problem
Yeah.
to distributed computing.
Yes. Yeah. So it's not so the problem with calculations, it's not really with the distributed computing. Distributed computing is excellent to perform the calculations, like you said. But the thing is, people confuse blockchain with distributed computing. Blockchain is distributed database that is consistent. It's a single database. But distributed computing is the other not completely, but the other aspect, not blockchain related. And you're right, you can have this architecture with the GPUs, master-slave architecture. You can have many more architectures. the best field of research that you can research the distributed networking right now are the sensory networks in sensory protocols like Zigbee. There are like thousands of them. I don't remember the names, but this is the field that you can research the distributed computing really well. And yeah, two more questions. I love answering questions.
One more, last one.
Yes. Ah, shit. Okay.
These are a round of applause from all of us.
Thanks. All right.
Not far enough, and
Yeah.
you don't have a t-shirt.
No, no, I
Oh
don't.
yes, you don't have a t-shirt. Now you have.
Thanks,
Thank you
Anna.
so
Thanks.
much.
Guys, I have no time for life right now. I'm doing this shit. I have like tight schedule, and I'm really glad to be here. Lviv is one of my favorite, if not my favorite city. I feel like home here, and every time I'm here, my mind is in the right place.
Whoa.
Thank you, guys.
Thank you.